Okay, Wildcats, today we're going to have 4. Logging on, solving logarithmic equations. Warm up. Use the properties of logarithms to rewrite each expression. Okay, let's take a look at number 1. So number 1 can be written as log base 3 of 8 plus log base 3 of x to the 4th, which can be rewritten as log base 3 of 8 plus 4 times log base 3 of x. All right, go ahead and finish up number 1. All right, let's take a look at number 2. Number 2 can be written as log base 2 of 5y to the 6th minus log base 2 of x to the 4th, which can be rewritten as log base 2 of 5 plus log base 2 of y to the 6th minus 4 times log base 2 of x. And then that can be rewritten as log base 2 of 5 plus 6 log base 2 of y minus 4 times log base 2 of x. All right, go ahead and finish up number 2. Let's take a look at number 3. Number 3 can be written as log of x squared minus log of y squared, which that can be written as log of x squared divided by y squared. All right, go ahead and finish up 1, 2, and 3 of the warm-up. Let's take a look at the next page. Getting started. Sound off. A decimal is a unit used to measure the loudness of sound. The formula for the loudness of sound is given by where dB is the decimal level, the quantity L0 is the intensity of the threshold sound, a sound that can barely be perceived. The quantity L is the number of times more intense a sound is than the threshold sound. Number 1. The sound in a quiet library is about 1,000 times as intense as the threshold sound, or L equals 1,000 L0. Calculate the decimal level of the quiet library. Substitute L equals 1,000 L0 into dB equals 10 times log base 10 of L divided by L0 and solve for dB. So dB equals 10 times log base 10 of 1,000 L0 divided by L0. Now, L0 divided by L0 is 1, so that's equal to 10 log base 10 of 1,000, which let's go ahead and put that in decimals. The decimal level of a quiet library is 30 decibels. All right, go ahead and finish up number 1. All right, let's take a look at number 2. The sound of traffic on a city street is calculated to be 500 million times as intense as the threshold sound. Calculate the decimal level for the city traffic. Substitute L equals 500 million L0 into dB equals 10 times log base 10 of L divided by L0 and solve for dB. So dB equals 10 log base 10 of 500 million Well, L0 divided by L0 is 1, so then that becomes 10 log base 10 of 500 million. Let's go ahead and plug that into decimal. which let's round that to a whole number, so 87. So the decimal level for city traffic is 87 decibels. All right, go ahead and finish up number 2. Let's take a look at number 3. The sound of a crying baby registers at 115 decibels. How many times more intense is the sound than the threshold sound? Substitute dB equals 115 into dB equals 10 times log base 10 of L divided by 9 and solve for L. So you have 115 equals 10 times log base 10 of L divided by L naught. Okay. So first step is we're going to divide both sides by 10. That divided becomes 1. Do is 11.5 equals log base 10 of L divided by L naught. Raise both sides by 10. This cancels. So then we have 10 to the 11.5 equals L divided by L naught. Let's cross multiply. So L times 1 is L equals 10 to the 11.5 L naught. All right, go ahead and finish up number 3. All right, let's take a look at the next page. Activity 4.1, solving logarithmic equations. While most medications have guidelines for dosage amounts, doctors must also determine the amount of time a medication will remain in a patient's body before it metabolizes when they write prescriptions. The amount of medicine remaining in a patient's body can be predicted by the formula, where T is the time in hours since the medicine was administered. C is the current amount of medicine remaining in the patient's body in milligrams. A is the original dose of the medicine in milligrams, and R is the rate of which the medicine is metabolized. Let's take a look at number 1. A patient is given 10 milligrams of medicine, which is metabolized at the rate of 20% per hour. How long will it take for 2 milligrams of medicine to metabolize? So we're going to substitute C equals 8, A equals 10, R equals 0.20 into T equals log base 10 of C divided by A divided by log base 10 of 1 minus R, and solve for T. So T equals log base 10 of 8 divided by 10 divided by log base 10 of 1 minus 0.20. Let's go ahead and plug that in Desmos. Equals 1. So it will take 1 hour for 8 milligrams of the medicine to remain in the patient's body. All right, go ahead and finish up number 1. All right, let's take a look at the next page. Suppose you know that 4 hours after administering a 12 milligram dose of medicine, 9 milligrams remain in the patient's body. How can you determine the rate at which the medicine metabolizes? You can solve for an unknown in the logarithmic equation by using the properties of equality and by rewriting the logarithmic equation as the exponential equation to isolate the variable. Go ahead and read over the worked example. All right. Go ahead and mark out 2 and 3. All right, let's take a look at the next page. Activity 4.2, determining efficient methods to solve logarithmic equations. You have analyzed different methods for solving exponential equations. There are also multiple methods of solving logarithmic equations. 1. Solve each logarithmic equation. Okay, let's take a look at the first one. Here we're going to raise both sides by 5. That cancels. You're left with x equals 5 to the 3.1. Let's just go ahead and put that in a calculator. Which let's round it to 1 decimal place, so 146.1 2.8. All right, let's take a look at the next one. Okay, here all we have to do is plug log base 8 of 145 in the calculator. So let's go ahead and do that. So let's round that to one decimal place, so 2.4 equals x. All right, let's take a look at the last one on this page. Here we're going to convert log to exponential. So we're going to rewrite this as x to the 6.7 equals 24. Okay, so we're going to graph the left side and the right side. So x to the 6.7 and y equals 24. And then we're going to zoom out. And then we're going to find the point of intersection, which is 1.6. Okay, go ahead and finish it up. All right, let's take a look at the next page. Go ahead and mark out that page. The teacher will solve and check 5A, 5B, 5C, 5D, 5E, 5F, 5G, and 5H on separate pages. Go ahead and mark out 6A and B. All right, let's take a look at 5A. So solve log base 4 of x plus 3 equals 1/2 and check. So the first thing we're going to do is raise both sides by 4. That cancels. You're left with x plus 3 equals the 4 to 1/2. So let's go ahead and get that number, which is 2. Subtract 3 from both sides. X equals -1. Okay, now let's check. X equals -1. So we're going to plug it back into the original equation. So log base 4 of -1 plus 3 equals 1/2. Well, we know the right side equals 1/2. Let's see if the left side equals 1/2. So zero point 0.5. 0.5 equals 1/2, so this checks. So x equals -1 is a valid solution. All right, let's take a look at the next page. All right. 5b, solve log base 4.5 of 9 equals x minus 1 and check. So the first step is going to add 1 to both sides. So you get log base 4.5 of 9 plus 1 equals x. All right, let's go ahead and plug that into our calculator. So that is, let's round it to one decimal place, so 2.5. So 2.5 equals x. Okay, now let's check. By plugging it back into the original equation, so log base 4.5 of 9 equals 2.5 minus 1. Well, 2.5 minus 1 is 1.5. And let's see if the left side equals 1.5 as well. If you round it to one decimal place, it does, so 1.5. So this checks. So x equals 2.5 is a valid solution. All right, let's take a look at the next page. 5c, solve log base x plus 2 of 7.1 equals 3 and check. All right, so to answer this question, we're going to convert log to exponential. So we're going to rewrite this as x plus 2 to the third power equals 7.1. We're going to graph the left side and right side and find the x value. All right, let's go ahead and do that. If we do that, let's press the home screen on the graph. Let's zoom out. Now, you're going to zoom out to see the point of intersection, then zoom in so you get a clearer view of the intersection, which is right here. So that is x equals negative 0.078. Okay, let's go ahead and check. By plugging that back into the original. So we know the right side equals 3. Let's check the left side. Which is 2.999, which rounds to 3. So this checks. So x equals negative 0.078 is a valid solution. Let's take a look at the next page. 5D. Solve log base 3 of 4.6 equals 2 minus x and check. So first step is we're going to subtract 2 from both sides. So you get log base 3 of 4.6 minus 2 equals negative 1x. Divide both sides by negative 1. So log base 3 of 4.6 minus 2 divided by negative 1 equals x. All right, let's go ahead and plug it into our calculator to get the number. Let's round that to one decimal place, so 0.6. Okay, now let's check. Well, we know that 2 minus 0.6 is 1.4. So let's see if the left side equals 1.4. It does. So 1.4 when you round. So then this checks. So x equals 0.6 is a valid solution. All right, let's take a look at the next page. 5e. Solve ln of x plus 4 equals 3.8. So first step is going to raise both sides by e. Cancels. You're left with x plus 4 equals e to the 3.8. Last step, subtract 4 from both sides. So x equals e to the 3.8 minus 4. So let's plug that into our calculator. Let's round that to one decimal place. So x equals 40.7. All right. Let's go ahead and check. We know the right side equals 3.8. Let's see if the left side equals 3.8. If you round to one decimal place, that's 3.8. So this checks. So x equals 40.7 is a valid solution. Let's take a look at the next page. 5f. Solve log base 11 of 12 equals x minus 7. So first step is we're going to add 7 to both sides. So you get log base 11 of 12 plus 7 equals x. Let's go ahead and plug that into our calculator. which equals, if you round to one decimal place, 8. All right, now let's check. So then let's log base 11 of 12, 8 minus 7. Well, 8 minus 7 is 1. Let's see if the left side is 1. If you round it to one decimal place, it is. So this checks. So x equals 8 is a valid solution. All right, let's take a look at the next page. 5G. Solve log base 1 minus x of 8 equals 14.7. So we're going to convert this to exponential, so that becomes 1 minus x to the 14.7 equals 8. At that point, we're going to graph the left side and the right side and find the x value. Let's go to home on the graph. Oh. So 1 minus x to the 14.7 and y equals 8. We're going to zoom out, find the point of intersection. We're going to zoom out, and then we have to zoom in so we don't click on the y-intercept, but we actually click on the point of intersection. So that is negative 0.152. Okay, let's go ahead and check. So then that's log of 1 minus negative 0.152 to the 8th power equals 14.7. You know the right side is 14.7. Let's see if the left side is. If you round to one decimal place, it's 14.7, which checks. So x equals negative 0.152 is a valid solution. All right, let's take a look at the next page. 5/8. Solve log base 10 of 4 minus x equals 1.3. Okay, we're going to raise both sides by 10. Cancels, you're left with 4 minus 1x equals 10 to the 1.3. We're going to subtract 4 from both sides. You get negative 1x equals 10 to the 1.3 minus 4. Divide both sides by negative 1. So x equals 10 to the 1.3 minus 4 divided by negative 1. All right, let's go ahead and plug that into the calculator. Which, if you round that to one decimal place, rounds to negative 16.0. Okay, so let's go ahead and check. Now, we know the right side is 1.3. Let's see if the left side does. If we round to one decimal place, it does, 1.3. So this checks, so x equals negative 16 is a valid solution. All right, let's take a look at the next page. Activity 4.3, solving logarithmic equations with multiple logarithms. If a logarithmic equation involves multiple logarithms, you can use the properties of logarithms to rewrite the equation in a form you already know how to solve. Go ahead and mark out number 1. Let's take a look at B. Solve log base 10 of 5 plus log base 10 of x equals 2. Check your work. So the addition becomes multiplication, so this becomes log base 10 of 5x equals 2. I'm going to raise both sides by 10. Cancels, you're left with 5x equals 100. Divide both sides by 5. X equals 20. Okay, let's go ahead and check. Now we know the right side equals 2. Let's see if the left side does. Does, so x equals 20 is a valid solution. All right, let's take a look at the next page. The teacher will solve 2a, 2b, and 2c and check on separate pages. All right, go ahead and mark out 3. Let's take a look at the next pages. 2a, solve log base 5 of 45x minus log base 5 of 3 equals 1. Okay, so this becomes log base 5 of 45x divided by 3 equals 1. Okay, we're going to raise both sides by 5. Cancels. 45x divided by 3 is 15x. 5 to the 1 is 5. Divide both sides by 15. X equals 1/3. Okay, let's check. So then we have log base 5 of 45 times 1/3 minus log base 5 of 3 equals 1. We know the right side equals 1. Let's see if the left side does as well. It does. So x equals 3 is a valid solution. All right, let's take a look at the next page. All right, 2b. Solve log base 2 of 8 plus 3 log base 2 of x equals 6. Okay, first off, I'm going to rewrite this as log base 2 of 8 plus log base 2 of x cubed equals 6. Then we can rewrite this as log base 2 of 8x cubed equals 6. Raise both sides by 2. This cancels. You get 8x cubed equals 2 to the 6th. Is 64. Divide both sides by 8. 5 goes 1. You get x cubed equals 8. Take the cube root of both sides. You get x equals 2. All right, let's check. Log base 2 of 8 is 3, plus log base 2 of 2 is 1, so that's 3 times 1 equals 6. 6 equals 6, so this checks. So x equals 2 is a valid solution. All right, let's take a look at the next page. Two C. Solve ln of 18x minus ln of 6 equals 2. Okay, so I can rewrite this as ln of 18x divided by 6 equals 2. We raise both sides by e. This cancels. 18x divided by 6 is 3x equals e squared. Divide both sides by 3. X equals e squared divided by 3. Right, so let's go ahead and put that in our calculator. Let's round that to 1 decimal place, so x equals 2.5. All right, let's go ahead and check. Well, we know the right side equals 2. Let's see if the left side does. Which if you round to 1 decimal place, it does. So 2 equals 2, that checks. So x equals 2.5 is a valid solution. All right, let's take a look at the next page. Go and mark out number 4. 5. Elijah and Xander each solve the logarithmic equation 2 log 6 equals log of x minus log of 2. Explain why each student's method is correct. All right, go and look over Elijah and Xander's work. All right. Elijah is correct because he applied the properties of logarithms on each side of the equation and then set the arguments of each equivalent logarithm equal to each other to solve. Xander is correct because he set one side of the equation equal to 0, applied the properties of logarithms on the left side of the equation, and then converted to exponential form to solve. Let's take a look at the next page. The teacher will solve and check 6a, 6b, 6c, and 6d on separate pages. All right, let's take a look. 6a, solve 2 log of x plus 1 equals log of x plus log of x plus 3. So first off, I can rewrite this as log base 10 of x plus 1 squared equals log base 10 of x times x plus 3. Okay, now I can raise both sides by 10. Cancel, cancel. You're left with x plus 1 times x plus 1 equals x squared plus 3x. Let's go in FOIL. So x times x is x squared plus 1x plus 1x plus 1 equals x squared plus 3x. Now I can subtract x squared from both sides. This becomes 0, this becomes 0. 1x plus 1x is 2x plus 1 equals 3x. I can subtract 2x from both sides. So you get 1 equals x. All right, let's go ahead and check. All right, let's first check the left side. which let's round that to 0.6. All right, let's go ahead and put it in the left side. Which rounds to be 0.6. Is checked, so x equals 1 is a valid solution. Let's take a look at the next page. 6b. Solve 2 log of x minus 3 equals log of 4 plus log of x minus 15 divided by 4. Okay, so first I can rewrite this as log base 10 of x minus 3 squared equals log base 10 of 4 times x minus 15 divided by 4. I'm going to raise both sides by 10. Cancel, cancel. So with x minus 3 times x minus 3 equals 4x minus 60 divided by 4. That's 4. X times x is x squared minus 3x plus 9 equals 4x minus 15. We can go and subtract 4x from both sides, and we can add 15 to both sides. This all becomes 0. So then you're left with x squared minus 3 minus 3 minus 4 is 10x plus 9 plus 15 is 24 equal to 0. Now we know 2 parentheses equal to 0, x and x. Now we need to figure out what numbers multiply to give you a negative 10 combined to be a positive 24. So negative 1 times negative 24 is positive 24. Negative 1 minus 24 is negative 25. That doesn't work. Negative 2 times negative 12 is positive 24. Negative 2 minus 12 is negative 14. That doesn't work. Negative 3 times negative 8 is positive 24. Negative 3 minus 8 is negative 11. We're close, but that doesn't work. Negative 4 times negative 6 is positive 24. Negative 4 minus 6 is negative 10. That works. So our factors are x minus 4, x minus 6. So x minus 4 equal to 0, x minus 6 equal to 0. So x equals 4 and x equals 6. Let's check. So we're going to check x equals 4 first. So 2 log base 10 of 4 minus 3 equals log base 10 of 4 plus log base 10 of 4 minus 15 divided by 4. Let's check the left side first. Oop. Is 0. And then is 0. So that checks. So x equals 4 is a valid solution. All right, now let's check x equals 6. So it's 2 log base 10 of 6 minus 3 equals log base 10 of 4 plus log base 10 of 6 minus 15 divided by 4. Now, we already have those in, so we just need to change the 4 to a 6 in both locations. And it looks like those both round to 1, so 1 equals 1. So this check. So x equals 6 is also a valid solution. All right, let's take a look at the next page. 6c. Solve ln of x minus 3 plus ln of x minus 2 equals ln of 2x plus 24. Okay, so this can be rewritten as ln of x minus 3 times x minus 2 equals ln of 2x plus 24. Raise both sides by e. It cancels. Let's go ahead and FOIL that. That becomes x squared minus 2x minus 3x plus 6 equals 2x plus 24. All right, let's go ahead and subtract 2x from both sides. Subtract 24 from both sides. Becomes 0. You get x squared. That's minus 5 minus 2 is minus 7x minus 18 equals to 0. So when you figure out what numbers multiply to give you negative 18 combined to be negative 7. So 1 times negative 18 is negative 18. 1 minus 18 is negative 17. That doesn't work. 2 times negative 9 is negative 18. 2 minus 9 equals negative 7. That works. So our factors are x plus 2, x minus 9 equal to 0. So x plus 2 equal to 0, x minus 9 equal to 0. So x equals negative 2 and x equals 9. Let's go ahead and check. All right. So we get undefined. Once you get undefined on either the left or right side, that means that this doesn't check. And now we can say that x equals negative 2 is an extraneous solution. Extraneous solution is when it appears to be a valid solution, but it doesn't check. Okay? So now let's take a look and let's check x equals 9. So it's ln of 9 minus 3 plus ln of 9 minus 2 equals ln of 2 times 9 plus 24. All right, we can come back here and we just change all the negative 2's to 9's. So we get 3.7 equals 3.7 So this checks. So x equals 9 is a valid solution. All right, let's take a look at the next page. All right, 60. So we're going to rewrite this as log base 3 of x squared equals log base 3 of 4 times 16. Raise both sides by 3. Cancels, you get x squared equals 4 times 16, which we can use our calculator, is 64. Okay, we're going to take the square root of both sides. Remember, plus or minus. Cancels, you get x equals plus or minus 8. So x equals 8 and x equals negative 8. All right, let's go ahead and check. So that's 2 log base 3 of 8 equals log base 3 of 4 plus log base 3 of 16. All right, let's go ahead and do that. So that's 3.8. Which is 3.8. So this checks. So x equals 8 is a valid solution. Right now, let's check x equals negative 8. So 2 log base 3 of negative 8 equals log base 3 of 4 plus log base 3 of 16, which we already know that the right side equals 3.8. So let's take a look at here. All we have to do is change this to a negative 8. We get undefined. And then once you get undefined, then we know that this is an extraneous solution. An extraneous solution is what appears to be a valid solution, but it doesn't check. Okay, go ahead and finish that up. All right, let's take a look at the next page. All right, go ahead and mark this page out. Let's take a look at the next page. Go ahead and mark this page out. Go ahead and mark this page out. All right, go ahead and mark this out. The student works 2A, 2B, 3A, and 3B. So go ahead and mark out 1. All right, let's take a look at the next page. The student works 1A, 2A, 2B, 3A, 3B, and 4. All right, go ahead and start working on your assignment and have a wonderful Wildcat day.